let's say that we're trying to count how many things there are in a sequence of repeating items. So let's just say that we have a 3-question quiz. 3-question quiz. And on each response, let's say that the answer can be taken from the set of possible responses, which are going to be A, B, and C. So we'll just say that each question it's a multiple choice. You can answer A, you can answer B, you can answer C. And the question we might have is, how many responses are possible? So one way to begin mapping this out before we try to apply any sort of rule is just to start off with a node that says, okay, from here we're going to have, for question 1, a series of 3 possible answers. So we can answer A, we can answer B, or we can answer C. And this is just for question 1. So this first branch of this tree diagram just lays out the possible answers for question 1. For question 2, we have the same possible answers, but really the sequence depends on what our answer was for question 1. So if question 1 we responded A, question 2 we can still respond with A, B, or C. Question 1, if we answered B, for question 2 we can still respond with an A, a B, or a C. And for question C, or for question 1, if we had answered letter C, then question 2 we're still able to answer A, B, or C. And you can imagine that this tree is definitely going to get very large because at each branch we have 3 possibilities. So question 2, if, for example, if we answered AA for questions 1 and 2, for question 3 we could answer A, B, or C. Now that's going to be true of all of the branches that we have stemming into question 2. We can answer A, B, or C for question 3. Of course, drawing this diagram out, you can imagine that it's going to get fairly large. So let's think about how many branches we're going to have on this this third rung. Well, if for question 1, I imagine that there are, in this case, 3 possibilities. There are 3 possibilities. Now, each of those 3 possibilities is going to result in 3 more possibilities for question 2. So if I think about this as 3 families, each having 3 offspring, well, that's 3 times 3, right? Each of these 3 is going to have 3 additional branches coming off of it. So because there are 3 more responses, I'm going to have a total of 9 possibilities for just answering the first 2 questions. For question 3, now imagine that we have 9 families, each of which are going to have 1 offspring. So that means that this branch is going to have 3 possibilities, plus 3 more here, plus 3 more here, plus 3 more here, all the way down the line. So all 9 of these branches are going to have 3 more branches. And so by the time we get to the third rung, we're going to have all 9 of these question 2 branches, resulting in 3 more possibilities for question 3. So in total, if we had 3 9 times, we're going to have a total of 27 possible answers. Or as we would say, answer sequences. So you can imagine that this is really going to be, in our case, if we call this up here, let's suppose we call this set Q for quiz question, then really what we're looking for is Q crossed with Q, and that's going to produce these ordered pairs, AA, AB, AC, so on down the line. But then we're going to cross all of those ordered pairs with a third value, so we're going to have this Cartesian product of these 3 sets. And the way we denote how many elements there are, right, because this is a set of elements, and this is going to be A, B, and we can try to follow these B, C, and there are going to be 27 elements in this. Well, we can't just say Q crossed with Q crossed with Q is 27 because this is a set. So I have to have some notation for counting the number of elements in that set. And the way we do that is we use these brackets and then we insert our set inside of here. So we have some set right here, and this is going to be defined as the number of elements in the set. And so in our case, the size of the number of responses for the 3 quiz questions is going to be 27. So just by putting those two, kind of the absolute value, which is really what it is, that just means size of, just like the absolute value of 3 is 3 and the absolute value of -3 is 3, it just tells us how far apart we are relative to 0. So we have 27 elements in this set. And you can already see that what we are establishing here is this thing called a product rule, which says that if I'm going to do something n times, and each of those branches has, we'll say, 3 possibilities. So if I have n questions, each with 3 possible answers, where it's perfectly okay to answer A all 3 times because there are 3 different questions, then I will have 3 raised to the power of n possibilities. Now, one way in which that could vary is, suppose what we're trying to do is to arrange some sort of objects. So maybe what I have is I have 3 people. So let's just say in a separate example, we have 3 people. And what I want to do is I want to assign them as maybe leader, moderator, and checker. So we're going to have 3 people. We'll just call them person A, person B, person C. And we're going to assign them to 3 roles. So we're going to have roles of, we'll just say lead, moderator, and checker. So maybe this is a group of students who are going to do some sort of task. To count this, we have to remember that at each branch, there's going to be 1 fewer possible people to fill that next role. So we're assuming here that a person can't be lead, moderator, and checker at the same time. So in this context, if I imagine that each branch represents the type of role, so let's just say this first column will be the lead. Well, person A could be the lead, person B could be the lead, or person C could be the lead. So those are our possibilities for the lead. Now, we can't assign, if A becomes the lead, then A can't be the moderator. The moderator is only to be one of the remaining individuals who hasn't been selected. So we'll call this column moderator. And if the lead is person A, then the moderator could be person B or person C. If the lead ends up being B, then the moderator is allowed to be assigned to person A or to person C. And similarly, if person C is the lead, then A or B could be the moderator. Now, since we've now assigned, or we've looked at the possibilities of lead and moderator, now we have to incorporate the third role, which is the checker. And if A is the lead, B is the moderator, then C can be the checker. And that's the only possibility. A is the lead, B is the moderator, C is the checker. If A is the lead and C is the moderator, then B has to be the checker because that's the only role remaining. And here's kind of same thing. If B is lead, A is moderator, C can be checker, A can be checker if C is moderator, and then person B and person A here. Now, in this context, notice that the number of possibilities actually diminishes by 1 at each stage in the branch. So there are 3 possibilities for the lead, only 2 possibilities for the moderator, and 1 possibility for the checker. So if we think about this in a similar analogous sense, there are 3 families, each of which are going to have 2 children. Well, that's 3 times 2 equals 6 children. So you see there are 6 possibilities at this stage. And then if each of those children has a family and has an offspring, then each additional layer is only going to have 1, or each moderator is only going to correspond to 1 checker. Each family is only going to correspond to 1 offspring. So there's still 6 here. And that becomes our product, 3 times 2 times 1, which is 6. So there are 6 distinct possibilities there. What if we wanted to have lead, moderator, and checker, but we had 6 people? Well, if we had 6 people, then we could think about this as the lead could be one of 6 people. So imagine we had 6 nodes here, A, B, C, D, E, F. Each of those leads would correspond to only 5 possibilities for the moderator. So the moderator could only be one of the 5 remaining individuals that hasn't been selected for the lead. And then finally for the checker, there are still 4 people left, so there'll be 3 people unassigned, right? We're only trying to fill 3 different roles using 6 people. 6 times 5 is 30. 30 times 4 is 120. So there would be 120 possible assignments that could take place. Of course, we don't want to draw that out because we would have to have 6. We'd have to have a D, an E, and an F here. And then if A would be the lead, then only B through F could be the moderator. And we could repeat a similar type of process for each of the elements down the line. So this formulates what's known as the product principle or the product rule, which basically says that if you have, in this case, n people, or n items, maybe we'll say generically n items, to assign, and we're going to pick R of them. Okay, well, first of all, if there are n items, you can't pick more than n items, so we have to give this stipulation that R has to be at most n. You could select all n of them, you just can't select n plus 1 of them because there are only n individuals. So this is a stipulation that we have to place on that. So n items selecting R of them, according to this product rule, would say that there are n ways to fill the first role. There are n minus 1 ways to fill the second role. There are n minus 2 ways to fill the third role, etc. Now when we get to the rth role, so this is the rth person that we're selecting, well, if we're selecting only 2 people, it's n minus 1. If we're selecting 3 people, it's n minus 2. So if we're selecting R people, how many possibilities are left for that rth person? Well, notice that the pattern here is, well, if you think about this as n minus 0, then for the first roll, there's n minus 0. For the second roll, there's n minus 1. So by the time we get to the rth roll, there are going to be n minus R plus 1. So if this is going to be R, if this was 3, then this is n minus 3, excuse me, I think I have this backwards, n minus R plus 1, yes. So back here, when this was 3, this is really n minus, excuse me, this should be a R minus 1. That way here, if our index is 2, then we're doing n minus 2 minus 1, so n minus 1, n minus 3 minus 1, that's n minus 2, and so on down the line. Then to select all of these, we're going to take n times n minus 1 times n minus 2, all the way down, all the way down to multiply n minus R minus 1 in parentheses. And so that's the number of ways we can select R items from a total of n items. And now we have this thing called the product principle or the product rule for counting the number of events.